James Webb Telescope found a 200-million-year-old structure. The furthest globular clusters ever seen were found by scientists from the Canadian NIRISS Unbiased Cluster Survey Team using the James Webb Space Telescope. The initial and oldest stars in the universe may still be present in these dense clusters of millions of stars. So, what recent findings has the JWST made? And how would this finding affect everything else? Keep watching this video as we bring you more information about this exciting finding made by the James Webb Space Telescope. What did the satellite find? The first image of high scientific quality from NASA's newest satellite observatory revealed a hidden gem in the form of a glittering distant galaxy surrounded by dense clusters that may have some of the very first stars in the universe. The first deep field image from the James Webb Space Telescope, JWST, showed an amazing variety of galaxies. A team of Canadian astronomers has concentrated their efforts on the Sparkler galaxy, a galaxy 9 billion light-years from Earth that gets its name from the compact objects that surround it and give off a brilliant yellow-red glow. The galaxy is noteworthy for its peculiar stretched look. Still, the nearby objects that gave rise to the term are of great scientific significance, since they might be the farthest globular clusters of stars that astronomers have yet to uncover. NASA's Webb reaches new milestone in search for distant galaxies. The finding of the earliest confirmed galaxies has been reported using information from NASA's James Webb Space Telescope by a global team of researchers. Since these galaxies were formed earlier than 400 million years after the Big Bang, at this time the universe was just 2% of its age now, it took more than 13.4 billion years for their light to reach the Earth. Potential candidates for these young galaxies were suggested by Webb data. These targets were verified using spectroscopic investigations. This shows recognizable patterns in the light's fingerprints from these faint galaxies. It was critically needed to demonstrate that these galaxies existed in the early cosmos. According to the astronomer and co-author Emma Curtis-Lake from the University of Hertfordshire in the United Kingdom, it's extremely conceivable for closer galaxies to pass for very distant galaxies. Seeing the spectrum exposed as we had hoped, it confirmed that these galaxies are at the true edge of our field of view, some of which are farther away than Hubble could see. It is a mission accomplishment that is quite exciting. The near-infrared spectrograph and the near-infrared camera, NIRCam, two of the instruments on board Webb, were developed by scientists who worked together to produce the findings, NIRSpec. What inspired this? The primary inspiration for this equipment came from the study of the weakest and oldest galaxies. The JWST Advanced Deep Extragalactic Survey, JADES, which was an ambitious mission that had been allotted slightly over a month of the telescope's time spread over 2 years, was suggested by the instrument teams in 2015 and is to provide an unprecedented glimpse of the earlier cosmos in depth and detail. Over 80 astronomers from 10 different countries make up the worldwide partnership known as JADES. Marcia Reiki, a principal investigator for NIRCam at the University of Arizona in Tucson and a co-author on the paper, said that the results represent the pinnacle of why the NIRCam and NIRSpec teams teamed together to perform this observation program. The Hubble Space Telescope's ultra-deep field was the subject of the first wave of JADES observations. Almost all the major telescopes have been focusing on this little area of sky for over 20 years, creating sensitive data spanning the electromagnetic spectrum. The faintest and finest images ever seen are now being provided by Webb, which is adding its own perspective. The first component of the JADES program was NIRCam and used more than 10 days of mission time to monitor the field in 9 different infrared colors and provide beautiful photos of the sky. Also, the area is 15 times larger than the Hubble Space Telescope's deepest infrared photos, yet it is significantly deeper and crisper at these wavelengths. When seen from a mile away, the image is simply the size of a human. However, it is teeming with around 100,000 galaxies. Each of them was captured at a different point in their history, several billions of years ago. Brant Robertson, a co-author from the University of California, Santa Cruz, who is also a member of the NIRCam science team, stated that for the first time, we have identified galaxies barely 350 million years after the Big Bang. and we can be totally positive of their incredible distances. Finding these early galaxies in such exquisite photos is an incredible experience. The multi-wavelength colors of the galaxies in the early cosmos can be identified from these photos in a distinctive way. The cosmos is expanding and stretching the wavelength of light. The light from these newest galaxies has been stretched by a factor of up to 14. Astronomers are seeking infrared visible dim galaxies, whose light abruptly disappears at a crucial wavelength. The expansion of the universe causes the cutoff point within each galaxy's spectrum to move. The JADES team combed through the Webb pictures, searching for these distinguishable candidates. Then, they used the NIRSS device to collect data over a single observation period that lasted for 3 days and 28 hours. The scientists gathered the light from 250 dim galaxies in order to investigate the patterns that the atoms in each galaxy left on the spectrum. This gave an accurate measurement of the redshift of each galaxy, and also showed the characteristics of the stars and gas within these galaxies. Stefano Carniani, who is an astronomer at the Italian Scuola Normale Superiore and a co-author of the study, noted that these are greatly the weakest infrared spectra ever recorded. They show what we expected to see, a precise measurement of the light's cutoff wavelength caused by intergalactic hydrogen scattering. 4 of the galaxies under study are very noteworthy because they were formed at an unheard of early era. According to the data, which were confirmed by spectroscopy, these 4 galaxies are located at redshifts exceeding 10, including 2 at redshift 13. This opens up a new area in the search for distant galaxies because it corresponds to a time when the cosmos was roughly 330 million years old. Due to their immense distance from Earth, these galaxies are very faint. Thanks to Webb's incredible sensitivity, astronomers can investigate their characteristics now. The University of Cambridge in the United Kingdom's astronomer and a co-author, Sandro Takela, said, "It is difficult to understand galaxies without understanding the early stages of their growth. The effects of these early star generations have a significant influence on later events, much like with humans. We're excited that we are able to contribute to the answers to this mystery because so many questions about galaxies have been waiting for Webb's revolutionary potential." In 2023, JADES will carry on with a thorough investigation of a different field, this one centered on the renowned Hubble Deep Field, and return to the Ultra Deep Field for yet another round of deep imaging and spectroscopy. Can the telescope of James Webb Space really see the past? Webb will be used by researchers to investigate the creation of the universe. But how is that even doable? The James Webb Space Telescope made history on the 12th of July when it unveiled its first image, which is a gem-filled picture dubbed the deepest picture of the universe ever taken. The telescope can observe distant stars and galaxies as they appeared 13.5 billion years ago, not long after the beginning of the universe as we know it, looking farther back in time than any other telescope. In addition to looking farther across space than any observatory before it, the James Webb Space Telescope has another trick up its sleeve. How is it even possible? How is it that a machine may travel back in time? It is simply a property of light, not magic. According to NASA experts, a telescope may travel through time, and the universe is like a window into the past. It may sound confusing, but the process is actually quite straightforward. Light requires time to travel through immense stretches of space and reach us. It takes time for whatever light you see to get to your eyes, whether it's the glow from your desk lamp a few feet away or the twinkle of far-off stars. Interesting, light travels at an incredible speed of about 670 million miles per hour, so you won't see it moving from, say, the desk lamp to your eyes. The majority of objects in the night sky are millions or billions of miles away, so when you look at them, you are actually witnessing light that has come a very, very long way to reach you. That being said, we'll just have to wait and see what else the James Webb Telescope will discover deep inside space. Thanks for watching.